Hi, today we will be discussing the Pythagorean theorem. But before that, in our previous video, we ended off with a question. Given that this is a right triangle with side lengths 3, 4, and 5, what is the value of sine of theta? Well, if you remember from our mnemonic SOHCAHTOA, we have that sine is equal to over h right here, or that sine of theta would be equal to the opposite over the hypotenuse. So our hypotenuse is 5 because that's the greatest value, and our opposite value is going to be the value of the side opposite from theta, which is 3. So that means that sine of theta must be equal to 3 over 5. Okay, but we have another problem here. How do we know that these three values are going to be correct for a right triangle? And to do this, we need to know the Pythagorean theorem, which will link these three values and make sure that this is a valid right triangle. Okay, so let's go back to the Pythagorean theorem, which is going to be the topic of this video. So say we have our triangle right here. It's a right triangle. And we have the value A, B, and C. C is our hypotenuse. So how can we link these three values together, these three side lengths together? The Pythagorean theorem states that a squared plus b squared is equal to c squared. And we'll be proving this theorem in this video. So how can we prove the Pythagorean theorem? Well, let's first draw our right triangle once. So we'll be having to draw this many times in this proof, but okay. So we have one right triangle. So let's just define some values. We can call this as A, this B, and this C. This can be alpha, and this can be beta. Okay, so let's draw another triangle, I mean. It's going to be identical to this one. And this might not be perfectly to scale, but yeah. Okay, so here it is. We'll draw another one. And we'll draw yet another one. So we need 4. And this doesn't look perfect, but it'll do the job. So this is a right angle, this is a right angle, and this is a right angle. So we have that this is beta, this is B, and this is A, this is B, and this is A. And so we have this tiny square, and given that this is also fully perfect, these are all four perfect right triangles, this bigger shape is also a square. And we can also note this, that alpha and beta, they're complementary. That means that they add up to 90 degrees. And so that this is a right angle, this is a right angle, this is a right angle, and this is a right angle. And they all have the value c. So that means it has to be a square because all four sides have the same side length. So what is the side length of this tiny square? Well, we have that this longer value is b right here, which I'll draw in green. So this is b. And we have a right here. So if this is b and this smaller value is a, that means that this has to be equal to b minus a. Or if you write the side lengths differently, this would be a minus b. So the area of this small square is equal to, I'll put this back to another color. So the area is going to be equal to b minus a squared. And if we were to expand this, that means that this is equal to b squared minus 2ab plus a squared. no matter whatever value you get for this b minus a or a minus b, we're going to get the same value, same result. So we have the area of the small square is b squared minus 2ab plus a squared. And what are the areas of these four triangles? Well, we know that the area of a triangle is 1/2 times the base times the height. So if this part is the base and this is the height, that means that the area of each of these triangles, because they have the same side lengths, is equal to 1/2 a times b. And because we have four of these, we're going to multiply this by 4, which is 2ab. And so we get that c squared, which is a big square, is equal to the small squared, the area of the small square, which is b minus a squared. And because we have those four right triangles, which have together a value of 2ab, so this is the value of c squared. And if we were to expand this once again, this is b squared minus 2ab plus a squared plus 2ab is equal to c squared. And you might see here that this negative 2ab and this positive 2ab cancel. And so we finally get our desired result, which is c squared is equal to a squared plus b squared, or that a squared plus b squared is equal to c squared. And you might also see this in a different way, as c is equal to the square root of a squared plus b squared. So these are the two different ways you can express the Pythagorean theorem. But back to the beginning of this video. In the beginning of this video, we solved that other sine value question, wherein the side lengths of our right triangle, this is so not to scale, but so that we had, this is a right angle, this is 3, 4, and 5. So is this a valid right triangle? Well, we can plug these values into the Pythagorean theorem. So it doesn't matter which one is a or b, but 3 and 4 have to be a and b in any order, and 5 is c because it's the longest value, it's the hypotenuse. So we have 3 squared plus 4 squared is equal to 5 squared, and we're going to check if this is equal. Well, 3 squared is 9, and 4 squared is 16, and 5 squared is equal to 25, and this is true. So that means that a 3, 4, 5 right triangle is a true, valid right triangle. So thank you for watching, and we will be, in the next video, we'll be discussing trigonometrical identities by which we can solve many other types of problems. And just before we leave, I'm going to give you guys a challenge problem. And if you find the answer to this problem, you can just post it in the comment section below, and I will be starting off with the answer to this problem in the next video. So this is a right triangle, and we have the values 12 and 13. So 13 is our hypotenuse, and 12 is one of the sides, one of the shorter sides. So what is x if x is the other side? So find x, that is your problem. So you can post the solution, what you think is the correct answer, in the comment section below, and we'll be starting with this in the next video. So thank you for watching, and I hope you guys understood and learned these topics which I discussed today, the Pythagorean theorem, and see you again in the next video. Thank you.